Sometimes part of your sketch involves showing an image from the disk. This is really easy to do. The key to making it work is a new kind of object called a p-image. Notice that the p and the I are both capitalized. P-image describes a kind of object, just like int or string. To use it, we declare a variable to be of type p-image. Here I'm declaring a variable named picture of type p-image, so it's ready to hold an image from the disk. To load that image into picture, we call loadImage, with a capital I there in the middle. LoadImage takes one argument, and it's the complete path name to the file you want to show. As of right now, processing can read in a file in JPEG format, also Targa, TIFF, and PNG, but JPEG is probably the most common. Once you've done this, the variable picture holds a picture, here a photograph that I took in New Zealand. Of course, we can roll both of these lines together into one, declaring the variable and loading its value all in one line, just by writing it all together in one line. Now that we have this image stored inside the variable picture, how do we display it on the screen? That's easy. We call the routine image. It takes 3 arguments: the name of the picture we want to show, and the X and Y of its upper left corner. So here's our graphics window, and suppose that, using this picture, I call image with the arguments picture 150. Then using the point 100,50 as its upper left corner, processing will show the picture. And this is what you'll get in your sketch. It's just that easy. If you'd like to resize the image before you show it, processing lets you do that too. You'll add 2 new arguments to image: the width and height that you want the image to take. Now this doesn't crop the picture, it just rescales it. So if I were to call image with the same picture, the same upper left corner, but now I give it 2 more arguments for the width and the height, then at the same point, 100,50, processing will place our picture, but it will resize it to be 100 pixels wide and 100 pixels high. That's really all there is to p-image and displaying a picture. Let's take a look at a few examples. Here's a little sketch. First, I create a global variable. It's of type p-image, and I call it myImage. Then I create a string that holds the path to the image. Here, nztrip.jpg is in the folder just above the folder where this sketch is stored. Setup does the usual first few things, smooth and size, and then I actually load the image into the variable called myImage. Finally, draw does just what we would think. It clears the background and it draws the image. In this case, the upper left corner for the image will be 4040. So let's run this and see what happens. And here we are. The image is displayed, the upper left corner is at 4040, and the window is large enough to hold the whole picture. So we get to see the entire image. Let's look at some more examples. Here's another program. It looks just like the program we saw before. There's only one change. In the last line of draw, when I draw the image, I give it all 4 arguments. First, the name of the variable that holds the picture. Then the upper left corner is 0, 0. And I say that the width of the image should be the current X position of the mouse. And the height of the image should be the current Y position of the mouse. Remember that mouse X and mouse Y will both be 0 when the mouse is in the upper left corner of the window. And as the mouse moves, those numbers change. So every time I call image, the upper left corner of the picture is at 0, 0, and the bottom right corner is exactly where the mouse is. So now I can move my mouse freely anywhere in the window, and the bottom right hand corner of the picture always tracks me. And all it took was giving image those extra 2 arguments. Because the function called image uses coordinates on the screen, it naturally obeys all the transformation commands that we saw in previous weeks: rotate, translate, and scale. In this sketch, I'm using rotate and scale to follow the mouse. So as my mouse moves towards the middle of the screen, the picture gets smaller. And as I spin the mouse around the center, the picture spins, always following my mouse. So this is kind of a fun little interactive thing for manipulating an image. And all it took was calling rotate and scale before I call image. What if you want to have a lot of images on the screen? Well, that's no problem. Just have a whole bunch of image variables and draw each one. Here's a whole bunch of pictures, which I'm drawing using rotate and translate and scale. As I move my mouse around, I can rotate the pictures, and as I move my mouse in and out, I can scale them. So this is another fun little toy that you can write for manipulating images. Again, using rotate, translate, and scale. All the transformation commands that we saw before work just fine, whether you're manipulating rectangles or Bezier curves or images. And this is kind of fun. I just saved a bunch of pictures and dropped them in. It was easy to write, and you can think of lots of variations on this program to create fun little interactive pieces. If you like, you can take the interactivity out, of course, ignore the mouse, and write some sort of a loop to change the parameters over time and create a nice animated piece. So to recap, we create a variable inside of processing to hold the picture. The variable is of type pImage, where the P and the I are both capitalized. The value that we put into there is the result of calling loadImage, which has a capital I. LoadImage takes one argument, a string, that identifies where the file is, and this string is relative to where you store the sketch. Once you've created this variable, you can draw the picture on the screen by calling image. It takes three arguments, the name of the variable that holds the picture, and the upper left X and Y that tells processing where to draw the picture. You can add two additional optional arguments to image, telling processing the width and height it should use to scale the picture before it draws it. Remember, it doesn't crop it, it doesn't throw anything away, it just smushes the picture together or stretches it apart to make it fit the width and height you've given it. This is really everything you need to know to read a picture from the disk and display it in your sketch. Using image and the transformation commands, you can now put an image anywhere you want on the screen, at any size, in any orientation. And even better, you can animate all of those things over time.